Now today discuss about boundedness property. Is a familiar property. Now we discuss boundedness property. First we discuss about largest element of is largest element and smallest element. Then bound and upper bound and least upper bound and also bounded below and the lower bound and greatest lower bound. Then we discuss least upper bound property and greatest lower bound property and then gives the example of this. Okay, so we first start about that largest element. Suppose that a is a set ordered by the relation less than. A is a set ordered by the relation less than. Ordered by the relation less than. Let A0 be subset of A, and the element B is the largest element. The element B is the largest element. Largest element of A0 if B belongs to A0, if B belongs to A0 and if x less than equal to B for all x belongs to A, for every x belongs to A0. Okay, that means suppose A is a set ordered by the relation less than A0 subset of A. The element B is the largest element of A0 if B belongs to A0 and if x less than equal to B for every x belongs to A0. Now this one is the largest element. Similarly, A is the smallest element of A0. A is smallest element of A0 if A less than equal to x for every x belongs to A0. Okay, that means smallest and largest element and smallest element obviously belongs to this set. Okay, largest element and smallest element obviously belongs to this set. Okay, but now we discuss about bounded above or bounded below and upper bound and lower bound and supremum and infimum. Okay, so first we start about bounded above. The subset A0 of A, the subset A0 of A is bounded above if there is an element B of A. There is an element B of A. There is an element B of A such that such that x less than equal to b for every x belongs to a0. Okay, bounded above if all elements upper bound, then all elements is less than this element b. Now upper bound, then we called this one is bounded above and the element b is called upper bound. The element b is called upper bound for a0. If the set of all upper bounds for a0 has smallest element, if the set of all upper bounds have a smallest element, this element have the smallest element, the element is called least upper bound. The element is called least upper bound or supremum of a0. Okay, that is, this one is bounded above, this one b is called upper bound, and the least, thus if the set of all upper bounds have a smallest element, then the element is called least upper bound. Okay, so we are all understand, that means the upper bound and least upper bound. Least upper bound is not the largest element. Largest element belong to this set, but least upper bound or supremum either belong to set or does not belong to set. Now discuss about lower bound. So we erase this portion. Now a0 is bounded below. a0 is bounded below if there is an element a of a. If there is an element a of a such that a less than equal to x for each x belongs to a0, then a is called then a is called then a is called a lower bound. Then a is called a lower bound of a0, and if the set of all lower bounds for A0 has a largest element, if the set of all lower bounds has a largest element, the element is called greatest lower bound, or the infimum of A0, or the infimum of A0. Okay, now we discuss about least upper bound property. An order set A is said to have the least upper bound property. An ordered set A is said to have the least upper bound, the least upper bound property if every non-empty subset A0 of A, if every non-empty subset A0 of A that is bounded above has a least upper bound. Now we write greatest lower bound property. Okay, we erase our portions also. An order set is said to have greatest lower bound property. If every non-empty subset if every non-empty subset is 0 of A that is bounded below has a greatest lower bound. Okay, now we discuss one example, then this one is clear. And what is the difference between smallest element and greatest lower bound element, and largest element and least upper bound element? This difference is clear if we discuss some example. Okay, so we erase the portions. Now we consider the set A equal to -1 1. The set of the set of all real numbers are in usual order. Then, assuming the fact that the real numbers has least upper bound property, it follows that the set has a least upper bound property. A has least upper bound property. And A has an upper bound, and least upper bound must be in A. Its least upper bound must be in A. A has an upper bound, but least upper bound B1 does not belongs to A. Okay, now we see that the subset 1 minus 1 by 2 and n belongs to Z plus. Then has no largest element. Does have a least upper bound in A. The number is 0. Has no largest element, but least upper bound B0. Upper bound B0. Okay. Now discuss another example. We consider the set -1 0 union 0 1. Okay, does not have the least upper bound property. Okay, does not have the least upper bound property. Least upper bound property. this set minus 1 by 2n such that n belongs to Z plus have bound be bounded above be bounded above but least upper bound 0 does not belongs to B. Okay, so we understand boundedness property. Today stop here.